This video is to introduce you to isotopes, atomic number, and mass number. The learning goal is to be able to calculate the number of protons, neutrons, and electrons in an atom. You will need your number 7 note sheet from the crate, and you will also need a periodic table of the elements so that you can refer to it to find some of the answers. First, we're going to talk about your vocabulary term, atomic number. The atomic number is specific for each element and the same for all atoms of that element. So each of the 118 known elements has its own unique atomic number. It is equal to the number of protons in that atom. When you look at your periodic tables, the atomic number is typically a whole number that is at the top of the element square. Go ahead and draw an arrow to label the atomic number for the sodium that you have on your paper. So sodium has an atomic number of 11, which means it has 11 protons. Hydrogen has atomic number 1. Every hydrogen atom has 1 proton. You can find hydrogen in the top left corner of your periodic table. Carbon has atomic number 6. That means every carbon atom has 6 protons. Copper has an atomic number of 29, so every copper atom has 29 protons. Gold has atomic number 79, so every gold atom has 79 protons. You learned in the last video that if the number of protons were to change, which does not happen very often, it would actually change the identity of the atom to that of a different element. Go ahead and pause the video here and use your periodic table to find nitrogen, N, sulfur, S, and barium, Ba, to determine how many protons each of these has. Nitrogen has atomic number 7, therefore it has 7 protons. Sulfur has atomic number 16. That means it has 16 protons. And barium is located at atomic number 56, which means barium has 56 protons. Atoms are neutral, which means they do not have an overall charge. It doesn't have more protons or more electrons. It has an equal number of both. This means that a neutral atom of calcium, atomic number 20, contains 20 protons and 20 electrons. It has 0 net charge because the 20 positives cancel out with the 20 negatives. Mass number represents the number of particles in the nucleus. We learned previously that the number of protons plus the number of neutrons gives us the mass number, because those are the only 2 particles that have mass. The mass of the electron, remember, is so small that we can just ignore it. The mass number does not appear on the periodic table because it applies to a single atom only. The mass that you see at the bottom of each element square on your periodic table is an average of all the masses of all the isotopes that make up any given element. If you go on to take chemistry, you will learn more about how they calculate the average atomic masses found on the periodic table. For this course, we will focus on the mass number of each individual atom. We can calculate the number of neutrons in an atom from its mass number and from its atomic number. If you subtract the atomic number from the mass number, that gives you the number of neutrons. Potassium has a mass number of 39 and an atomic number of 19. To find the number of neutrons, subtract the atomic number from its mass number. 39, the mass number, minus 19, the atomic number, equals 20, which is the total number of neutrons. Another example would be, if you have 100 cats and dogs, and you know that 40 of them are cats, 100 minus 40, 60, has to be the number of dogs. This table shows several common elements, their symbols, the atomic numbers, the mass numbers, and then the number of protons, neutrons, and electrons. By the end of this unit, you should be able to calculate the number of protons, neutrons, and electrons just by knowing an element's atomic number and the atom's mass number. You can pause here again for a quick learning check. Refer to your periodic table of elements to find zinc, which is Zn. To answer number 1, how many protons are in the nucleus, you had to find zinc on the periodic table and see that its atomic number is 30, which gives us the number of protons. Remember, since it's a neutral atom, it also has 30 electrons. How many neutrons are there? If we know that there are 65 total masses in the nucleus, that's the mass number, and we know that 30 of them are the protons, then the 35 that are left over have to be neutrons. C adds a little bit of a twist. What is the mass number of a zinc atom that has 37 neutrons? If we take the 37 neutrons and add them to the 30 protons that we know are there because that's the atomic number of zinc, then we get 67 as the total mass number for that atom. Here's another quick learning check. An atom has 14 protons and 24 neutrons. What is its atomic number? What is its mass number? What is the element? The atomic number equals the number of protons, so therefore it is 14. The mass number equals the protons plus the neutrons. 14 plus 20 equals 34. And what is the element? If you look at your periodic table and find number 14, you will find that it is symbol Si, silicon. Isotopes are atoms that have the same number of protons, the atomic number, which means they're also the same type of element. But isotopes have a different number of neutrons, therefore they have different mass numbers. All elements have isotopes, even though for many elements, the isotopes are not very common. Nuclear stability is affected by the mass number. Otherwise, all isotopes of a given element have essentially the same chemical and physical properties. Isotopes are named according to their masses. For example, carbon-12 means carbon 12, an atom of carbon with 12 total protons and neutrons. Carbon-14 is carbon with a mass of 14, and uranium-238 is uranium with a mass of 238. Go ahead and label the names carbon, carbon, and uranium, and the mass numbers 12, 14, and 238. Another way that we can represent isotopes is by using their chemical symbol. You may have noticed that on the periodic table of elements, every element has its own unique symbol. C stands for carbon, and U stands for uranium. In a chemical symbol, we are shown the symbol, the mass number, which is given at the top left corner. Go ahead and label these. And oftentimes we are also shown the atomic number. This is at the bottom left corner. Notice for the two carbon atoms, the atomic number 6 is the same. This is the identifying number. We know carbon has 6 protons. For each of these symbols, we can determine the number of protons, electrons, and neutrons based on the information that we've learned so far in this video. For the first carbon, we look at the atomic number to find the number of protons to be 6. So go ahead and write that in. We also know that it is a neutral atom, so there must also be 6 negative electrons. To find the number of neutrons, we take the mass number 12, subtract the number of protons, 6, and we're left with 6 total neutrons. For the middle carbon atom, we have the same number of protons and the same number of electrons because that's given by the atomic number. But here we have 13 minus 6, so we end up with 7 neutrons. And for uranium, the atomic number gives us the number of protons, 92. It also gives us the number of electrons, 92. And to find the total number of neutrons, we take 238, subtract from that the atomic number of 92. So we end up with 146 neutrons. We are going to address the table at the end of your notes in the next video. So go ahead and grab worksheet number 8 and use the data and information that you got from this video in order to complete all of the questions on that worksheet.